Okay, so on to question 3. How do you calculate the electrochemical cell potential Ecell with a solved example? So to calculate for Ecell, we are going to use the Nernst equation. So this is the potential of the cell. Then I'll just define everything as we go along. Okay, so E cell is the cell potential. And this is in non-standard conditions. Ecell, I'll define down here. Okay, so Ecell is the difference of standard reduction potential of the cathode with the anode. So it's pretty much the difference between the two. So R is a constant. So its value is around 8.31 joules over mole times Kelvin. T is the temperature in Kelvin. F is another constant, and it's called Faraday's constant. So its value is 96,485 coulombs over mole of the electrons. And finally, N is the number of electrons transferred. Okay, so let's see what the junior tutor said, because I believe they have a solved example. So the galvanic cell is made of 2 electrodes, and its potential is the difference between the reduction potential of the electrodes. The electrochemical cell potential can be calculated using Nernst equation. So in order to find the cell potential at non-standard conditions, we must calculate the electrochemical cell potential at standard conditions. So this is the Ecell. It is equal with the difference of standard reduction potential of the cathode with the standard reduction potential of the anode. Yep, so that's what I wrote down here. Standard reduction potentials of the electrodes are constant values, and they are found in appendices by Internation Agreement, standard electrode potential measures the tendency for a reduction process to occur at standard conditions. Standard conditions are absolute temperature, which is 298 Kelvin. Molar concentration of the ions in the half cells is 1 mole per decimeter cubed, and pressure of the gases is 101,325 pascals. So they have R as the universal constant of gases equal to 8.31 joules over mole times Kelvin. T is the absolute temperature in Kelvin. And F is Faraday's number. It expresses the amount of charges of 1 mole of electrons. Okay, so instead of N, they have Z. So Z is the number of moles electrons that are transferred in the redox reactions. To find that, we must write the overall equation that occurs in the galvanic cell. Q is the quotient equilibrium of the chemical equation that occurs in the cell. Okay, so they have an example here. Calculate the cell potential of a galvanic cell at 300 Kelvin, in which the chemical equation is the following. So they have a chromium ions plus protons plus iodine makes Cr3 plus, iodine, and water. They also give the molar concentrations of all of the different ions. So 2 mole per liter, 1, and 1 times 10 to the negative 5. Okay, so now they have a step-by-step solution. In the first step, we should write the half reactions on both half cells. At the anode occurs oxidation. The element oxidized is iodine because it changes its oxidation number from -1 to 0. So that means its oxidation number increased, so that's how we knew that the iodine is what got oxidized. At the cathode occurs the reduction. Element reduced is chromium because it changes its oxidation number from +6 to +3. So it had a decrease in oxidation number, so that's how they knew that it was getting reduced. So notice that they write the two half reactions from the main chemical equation. So they just took out the iodine, which is what got oxidized, and then this produced the 3 molecules of I2. And then the reason they put 6 electrons on the right side is to balance out the charges. So notice that the iodine has a -1 charge. They needed to add the 6 electrons on the right side to also have a -1 charge. And similarly with the chromium, they have plus the 14 protons plus 6 electrons makes 2 chromium 3 plus 7 H2O. So again, notice that the total charge on the left side is -2 plus -6, which is -8. And then you want to add plus 14. So that's pretty much the same as 14 minus 8, which is 6. So notice our reactants have a +6 charge. And then on the product side, we have 2 chromium 3 plus ions. So our right side is also +6. So we know that the two are balanced in both charges and also with atoms. And they also have the potentials of the cathode and the anode. So I'm assuming this should also be given in the equation as well. And now they have the overall reaction. And then next it says the reactions above can be used to find the number of mole electron Z and also write the expression of the quotient Q. So Z is equal with 6 electrons because that is the number of transferred electrons. Yep. So now they have the expression of Q. So these are quotient values. So they have the notice how they're only using the ions that are involved, and when you have pure substances like solid and liquid, so in this case the iodine and the water, these aren't included in the expression of Q. So it's going to be products over the reactants. So the only product here would be the chromium 3+, and the reason it's to the power of 2 is because in our balanced chemical equation, there is a coefficient of 2. So that is our only product. Our reactants are the chromium 2- ion, the proton to the power of 14, and the iodine to the power of 6. And now they inputted the given concentrations from the question. So the concentration of chromium 3+ is 1 × 10⁻⁵, and the concentration of this is 2, proton is 1, and the iodine is also 1. And they got Q to be equal to 5 × 10⁻11. In the third step, we should calculate the standard cell potential Ecell. So these values were given in the question during this step. So they did 1.33 minus 0.54, and they got 0.79. Okay, so now in the last step, we can calculate the electrolytic potential cell at non-standard conditions using the Nernst equation. Okay, so notice how they have it multiplied by ln Q. Yep, so now they're just plugging in all of the values. And they ended up getting 0.892 volts. Yep, so this solution is correct. So these types of questions are multi-step, and it requires you to really think about how to answer it. It's one of those questions that would be worth maybe like 10 or 12 on a midterm because of how many steps there are. Usually you have to balance your redox reaction, balance your anode and your cathode, and then you have to find the expression of Q and also understand how the Nernst equation works. Okay, so that solution is correct.